Hello, everyone. This is Global Math Mentor, and today we will be solving further mathematics paper 1 from the Cambridge International Exam. This is from May-June 2025 series, 2-hour exam. You can pause the video and quickly go over these instructions. 75 marks. Let's begin with question 1. Part A. Use standard results from the list of formula. So we know there's a formula document MF19 to show that this summation on this double bracket ends up a cubic expression where A, B, C are integers to be determined. So before you apply the summation, you need to expand the double bracket. And this will be 10 minus 6 and minus 15, negative 21r and plus 9r squared. Now we apply the summation 1 to n. This will be 10 minus 21r plus 9r squared. And we know that summation is distributive. It's supplied 1 by 1. When you add 10 n times, that's going to be 10 n. And minus 21, if you know the sum of the n integers, that's going to be n plus 1, and divide 2. And when we apply this same to the sum of squares, which is r squared, this will be n plus 1, 2n plus 1, and divide the whole thing by a 6. So I can simplify some of the terms, 10n. So before, we need to expand these brackets first. So n squared plus n and divide 2. And this will be plus, okay, let's just simplify it over here. N squared plus n times 2n plus 1. I would encourage you all to pause the video and you can solve it side by side, and you can always come back and check my work. Plus n. So I will have 3 over 2 times 2n cubed plus 3n squared and plus n, right? That's it. Okay, now let's proceed. We need a cubic expression, 21 over 2n squared minus 21 over 2n plus 3n cubed and plus 9 over 2n squared and plus 3 over 2n. Okay, so I've got an integer value for a because I've got a 3n cubed. And now I need to, you can use a calculator, but 21 and 9, the difference is 12. This will be negative 6n squared. And now we have a negative 18 divide 2, which is a negative 9 and plus 10, so plus n. And that is part A. Let's move on, and we can do part B. Use the method of differences to find the summation on this. Now we need the method of differences, which give us the telescopic sum or the collapsing sum. But we need to express this fraction as partial fractions first. 5 minus 3r. So how do you do that? That's going to be a over 2 minus a 3r plus b over a 5 minus 3r. So you can express as a single denominator. You can use this trick. It makes it easier. So just multiply the whole expression with the denominator on the left-hand side. This will give me the identity equation. A times 5 minus a 3r plus b times a 2 minus a 3r. Now, there are a lot of ways you can compare coefficients, or you can just assign values to. So what values should we assign? One of the value can be the root to this expression, which is a 5 over a 3. And the other one is going to be this one, which is r equals to a 2/3. So let's put them one by one. So when I apply 5/3, a will go away. 2 minus 3 times a 5/3 is going to be 5. So this will give me 1 equals to a negative 3b, and b is a negative 1/3. Okay? And similarly, when I apply this value, a will be eliminated. Sorry, b will be eliminated, and a will be 5 minus the 2, which is a 1 equals to 3a, and a is a 1/3. So my final partial fractions will be 1 over 3 times 2 minus 3r minus 1 over 3 times a 5 minus 3r. So I need to apply the sum 1 to n on this expression. And before you explore this method of differences, I think it's better if I can factor out the 1/3. Both values have that thing, r equals to 1 to n. And this is the part which is a bit annoying for the beginners, but with practice, you can apply this. So let's go one by one, and I'm going to be putting, let's say 1, 2, 3, and check like how the sum behaves. So when I apply 1, this is going to be, let's put a bracket over here. So 1, 2 minus a 3, it will be a -1. Use calculator if you want to. So 5 minus 3, that's going to be -1. 2. Right. Plus, now we substitute 2, or you can do it in your head. 1 over 2 minus a 6. So -1 over 4. And 5 minus 6 is a -1, but this will end up a +1. Oh, so I can see some of the terms. They always cancel. Some of the terms cancel out. I usually like to explore more just to get the pattern of the cancellation. So if you put a 3, 1 over 2 minus a 9, that's going to be -1 over 7. Minus, okay, that will be 5 minus a 9, which is a -4. So I will get a +1 over a 4. So, well, I can see this cancels this one, this cancels this one. So you'll be left with a -1/2 in the first term, and all the rest of the terms will cancel. So I'm going all the way to the next one. So I need now, let's say, n minus a 1. So this will be 1 over 2 minus 3 times n minus 1, minus 1 over 5 minus 3 times n minus 1. Okay? So, and finally, the last one is going to be the nth one, 1 over 2 minus 3n, and minus 1 over 5 minus a 3n. So before you cancel, you can simplify this and check what does this end up. This will be 5 minus 3n. Oh, I've got this term canceled as well. So minus 1 over this is going to be 2 minus a 3n. And that term cancels as well with this one, right? Wait, 5 minus, oh, sorry. That's going to be 5 plus 3. That's going to be 8 minus 3n, right? But still, these terms will cancel. With the, practice, you'll realize that this is what I'll be left with in the end. So 1 over 3, I have a -1/2 and plus a 1 over 2 minus 3n. Okay, so this will give me a -1 over 6 plus 1 over 3 times 2 minus 3n. And that should do. This is the sum by using the method of differences. All right? Last part. It's a deduction part, so I need to deduce this. Part C. I need to find the sum to infinity, like the infinite sum of this thing, and that's easy since I have this expression. So when the n approaches infinity, you can say that 1 over 3, 2 minus 3n will approach 0, and you'll be left with a -1 over a 6. And that's it for question 1. And this is question 2. The cubic equation, x cubed plus 2x plus 1 equals 0. So the roots are alpha, beta, gamma. Part A, find the cubic equation whose roots are alpha cubed minus 1, beta cubed minus 1, and gamma cubed minus 1. So we use a substitution. Let y equals to x cubed minus 1. So this implies that x cubed will be y plus 1, and x is going to be, since I need x as well, the cube root of y plus 1. So let's substitute and see what do we get. This will be y plus 1 plus 2 times the cube root of y plus 1, and plus 1 equals to 0. So I've got y plus 2 and -2 times y plus 1, a cube root. I need to cube both sides to get rid of this 1/3. So let's use the Pascal's triangle to expand this. This is going to be y cubed plus. Now this will be 3 times 2, which is a 6y squared, plus 3 times a 2 squared, which is 12y and plus 8. And this will give me a negative 8 and y plus 1. So that's a negative 8y and negative 8. So now y cubed plus 6y squared plus 20y and plus 16 equals to 0. That is the required cubic equation. So let's do the next bit. Okay, now we need find the value of, so this is basically the sum of the squares, all right, of the roots. So you need to square roots and add them. But how do you do that, right? So let's use the cubic expression y cubed 6y squared plus 20y and plus 16 equals to 0. Let me just check, have I written it correctly? Yep. So learn the identities. So I'll write a short way. That's like the squared, sum of the square is going to be sigma alpha squared minus 2 times sigma alpha beta. So like that's the sum of the products in pair, which will be alpha beta plus alpha gamma plus beta gamma, right? Okay, so I know I'm just using a shortcut because I know the roots are of the form alpha cubed minus 1, but you'll get it. Like, this is how you write it. So the sum is going to be of roots is a minus 6. The sum of the product in pair is going to be, this is a 20. Okay, so let's put it negative 6 squared and minus 2 times a 20. So this will give me a 36 minus a 40, which is a negative 4, right? And that's it. So let's see. Part C is now I need to find the sum of the cubes. Now there is an identity for this, but let me just show you the another way which is even beneficial to get the higher powers of the roots, right? So let's use a recursion formula. So define your Sn as this alpha cubed minus 1 raised to power n plus beta cubed minus 1 raised to power n and plus gamma cubed minus 1 raised to power n. And now, how do you write your recursion pattern? Sn plus 3 plus 6 Sn plus 2 plus 20 Sn plus 1 and plus 16 Sn. You can pause the video and take a note on this one. So let's see how this helps me. Put n equals to 0 to get the S3, like the cubed power of the roots, right? Plus 6S2 plus 20S1 and plus 16S0. So S0 is going to be easy. That's just 3. Because if you raise power 0, each of them will be 1 plus 20. And I got this value, the sum, which is a negative 6. And plus 6 times S2 is a negative 4 and S3. So how do we do that? Let's go. S3, which is the sum of the cubes, is so this negative 24 becomes a 24. This is 120, negative 120. So this becomes 120 and minus a 48, right? So this is going to be 144 minus a 48. So that's going to be, what will that be? So take out 40, that's going to be 104. Yeah, that's going to be 96. And that's it. That's my answer for part C. And that's it for question 2. Question 3. The sequence U1, U2, U3 is such that U1 is 5 and U sub n plus 1 is 6, U sub n plus 5. It's a recursion sequence given for n more than or equal to 1. Part A, prove by induction that U sub n is 6 to the power n minus 1 for all positive integers n. Okay, so there are some words that should be kept in mind while you start the proof, so I can lay out the basic statement. Let Pn be the proposition that for all n more than equal to 1, un equals to 6 to the power n minus 1. So now we do the base case. So what's the base case? You need to check this if the proof is valid for the least possible value. So n equals to 1. You can let n equals to 1. So we know that u1 will then be 6 to the power 1 minus 1. That is going to be 5. So you can say, we see that u1 is 5, so this is true. Hence, true for n equals to 1. Or you can say the base case holds. Now we do the inductive step. So what's the inductive step? You say let pk hold for k more than equal to 1 such that uk is 6 to the power k minus a 1. And we wish to show that uk plus 1 also holds. So you can say now consider uk plus 1 will look like we've got the recursion sequence, which is this uk plus 5. So I'm going to substitute the value of uk from the first uk. So that's going to be 6 to the power k minus 1 plus a 5. If you expand this, this is going to be 6k plus 1 minus 6 plus 5. So this will end up 6k plus 1 minus a 1. So you can say this shows, or you can say hence pk implies pk plus 1. Or you can write it like hence true. Okay? So therefore, by you can say, I'm going to write the short words, principle of mathematical induction for all n greater than equal to 1. uk is 6 to the power, u sub n is going to be 6 to the power n minus a 1, right? And that's my proof. Let's see what's the next part. Deduce that u sub 2n is divisible by un. Okay, so for this, I need to check what is u sub 2n. That is going to be 6 to the power 2n and minus a 1 over. So I need to check the divisibility. So I'm going to divide it by u sub n, and that will look like 6 to the power n minus 1. Now, if it is divisible, let's apply the method of difference of two squares and check how does it go. So this will be 6 to the power n minus 1 and 6 to the power n plus 1. You know this property in algebra. So let's cancel this out, and this will be 6 to the power n plus 1. Yes, hence divisible for all n greater than equal to 1. So by divisibility here, we mean that if any integer value you sub in for 6 to the power n plus 1, it's some integer. So it means that divisibility holds, right? And that's for question 3. Question 4. The matrix M is given by M is this thing. It's a product of two 2 by 2 matrices. And theta is within 0 and 2 pi. Part A, the matrix M represents a sequence of two geometrical transformations in the xy plane. State the type of each transformation and make clear the order in which they are applied. So just the name and the correct order is required. So the first one is going to be the right one, which is some rotation. And if you get confused by, like, one way is to memorize them, the other way is a trick in which you can guess. So let's say if theta is a pi by 2, I know it's a 90-degree rotation, by the way. So cos pi by 2 is going to be 0, sine pi by 2 is 1, a minus 1, and a 0. So check what is going on with the identity matrix. So your 1, 0 is now going to 0, 1, and your 0, 1 is going to minus 1, 0. So this is anti-clockwise 90-degree rotation about the region, but we just need to write rotation, right? Just the name, and followed by the second one is going to be clearly 1, 0. The x-axis is invariant, and this is a shear matrix with a shear factor 2. So you can just write shear, 2 marks, right? Names and correct order. That's it. Okay, let's see next part. Find the value of theta for which the transformation represented by M has a line of invariant points. So there is a path of eigenvalues as well if you take lambda 1. But simply speaking, you can apply the idea that when this matrix is applied to some point xy, you get the point on the same line. So that is what they mean by invariant line. So now I need to get M first. Okay, I can do it over here, but in your exam, obviously you'll do the solution in the next part. I just need M as a single 2 by 2 matrix. So this is going to be cos theta plus 2 sine theta. This will be a minus sine theta plus 2 cos theta. And I get a sine theta and a cos theta, right? Okay. So now this is being applied to some point xy. Okay, I can just multiply it over here. So x will be x times cos theta plus 2 sine theta and plus y times a negative sine theta plus 2 cos theta. And in the lower part, I will get x sine theta plus y cos theta. So I've got a 2 by 1 matrix, and this will be the same point, xy, invariant point, right? So it doesn't change. So I need the value of theta. Let me see. Oh, I've got more space, thank goodness. This calculation needs some more space. So what do we do now? We equate the x. I think the second point is better to equate. So the lower entry in the matrix plus y cos theta. We can put it y, and this will give me x sine theta equals to y and a 1 minus cos theta. So that's better. Y will be sine theta over 1 minus cos theta, right? And that is x. So now I can sub it in the first one, and that will give me, let's just do it over here. That will give me x cos theta plus 2 sine theta. And now here in place of y, I can just apply a sine theta over 1 minus cos theta. And this is, let's say, x over here. And this is going to be minus sine theta plus 2 cos theta. And put it equal to x. So now x gets eliminated, and now we need to simplify this. This will be cos theta plus 2 sine theta plus, or you can say, let's say, okay, let's just simplify it in another way. This is going to be, let's say, 1 minus a sine theta over 1 minus cos theta. That's better. And a minus sine theta plus 2 cos theta. Okay. So now I need to express it as a single denominator. This will be 1 minus cos theta and minus, which I can write as plus sine squared theta and minus 2 sine theta and cos theta, right? And now you can cross multiply the 1 minus cos theta, the single denominator. These calculations are a bit hectic, but that's the way to go. You can definitely look into the eigenvalue method. So you'll put the singular matrix determinant equal to 0. That's a good way as well, but we can work this way. Cos theta plus 2 sine theta. And if you have any problems you want to discuss with me, you can always comment down below in the video. So I'll get back to you as soon as I see your comment. 2 sine theta and cos theta. And this will be 1 minus cos theta and plus sine square theta and minus 2 sine theta and cos theta. So I can see I've got some cancellations which are possible. And there's a way in which I can solve this 2 sine theta. And this cos square, when goes to the other side, this will look like a 2, since that becomes a 1 sine square plus cos square. So minus a cos theta. So now I will get 2 minus 2 cos theta minus 2 sine theta equals to 0. And this will give me 1 minus cos theta minus sine theta equals to 0. Oh boy, 1 equals 2. I still need to maneuver it in order to solve this one. So how do you solve this kind of an equation? I hope you know. I mean, there are harder ways where you can form a compound angle form, but I think squaring is a better way. Sine squared theta plus cos squared theta plus 2 sine theta cos theta. And this is 1. This is 1 as well, and that is 1, so this cancels. So sine 2 theta is going to be 0. So on 0, I get a 0, a pi, a 2 pi, and so on. So I need to check my domain. Oh, so 0 and 2 pi are not included. So the only value where sine theta is 0 is going to be a pi. So theta's value has to be pi over a 2. Right? And that's it for question. Which one was this one? It's 4. Question 5. The curve C has polar equation. R equals to theta, e to the power 1/8 of theta for 0 to 2 pi, but a sketch C. It's a polar curve. So we put a pole over here, and this represents theta equals to 0. So we have positive theta values. And there's an exponential factor. So each time the angle from the pole will be a little further, and it's going to be an anti-clockwise spiral. So your course requires you should know when do you have a circle, a cardioid, or a Archimedean spiral, or a logarithmic spiral. So this is an exponential one. So we know that. Let's hope it becomes better. So it should be anti-clockwise and increasing each time from the origin. So it should look something like this. Okay. So part B, find the area of the region bounded by C and the initial line, giving your answer in the form this, where P, Q, R, and S are integers to be determined. So we need to be familiar with the area rule, which is the 1/2 r squared d theta. This gives me the area. So let's apply that. Area is going to be a 1/2. Let's pull it outside. R squared. So theta squared and e to the power, the square of 1/8 theta, that's going to be theta divide 4, and d theta, and 0 to 2 pi. So now I need to perform the integration by parts. So you can put the limits side by side, or you can just maybe work your way without the limits, and in the end, you can apply the limits, right? So there are clearly different ways in which you can integrate by parts. So I usually use the classical method. I hope you've learned this. Sometimes you can suppose u to be theta squared and dv to be e to the power theta divide 4 and d theta, and then you can plug in these values into the given formula. You can check it out in the formula booklet. So let's I'm going to use the classical method, which is theta squared goes out, and I need to integrate e to the power theta divide 4, and divide a 1/4 becomes a 4, and minus the derivative of theta squared, which is the 2 theta, and again 4e theta divide 4. So if you have any doubts, make sure you check the full solution. But I'm just skipping some steps and just performing integration by parts. But you can always comment, and maybe I can make a separate video on different types of integration for you, so you can check them out later. So I get a 4 theta squared, e to the power theta divide 4, And this is a classical repeated integration by parts case because integrating it once did not help. Okay, so let's go all over again. So 4 theta squared e to the power theta divide 4 minus 8. And I will get theta and 4e theta divide 4 minus 1 times 4e theta divide 4 and d theta. So this will give me 4 theta squared e to the power theta divide 4 minus 8 theta. Sorry, that's going to be 32 theta e to the power theta divide 4. And this will become plus, so I need to integrate it again. So 8 fours are 32, and 32 times another 4 will be there. So 32 times a 4, which is going to be 128, and e to the power theta divide 4. Okay, so that's my integration by parts plus c. Now I plug it back in the given expression that I had. So area is going to be a 1/2 of this thing. So let's divide each thing by 2. So 2 theta squared e theta divide 4 minus 32 becomes a 16 theta e theta divide 4 plus this is going to be 64 e theta divide 4. And I don't need c this time since it's a definite integral. Okay, so that will give me a 2 pi square is going to be a 4 pi squared. So 4 twice 8 pi squared e pi by 2. And now I get a minus 16 twos are 32 pi e to the power pi over 2 and plus 64 e to the power pi over 2 and minus, this is going to be 0, minus a 0, plus just a 64, right? Okay, so let me just see what I was required over here. This is going to be, so you can check that I can factor out, this will be 8 pi squared minus 32 pi and plus 64 and e to the power pi over 2 and minus 64. And that will be my answer for the area. Okay, so did a lot of work over here. Let's see what's next. Oh boy, there's another one. Part C. Show that at the point of C furthest from the initial line, this expression is true and verify that this equation has a root between 5 and 5.05. So they are talking about the point further from the initial line. So that's going to be a y coordinate. So let's put y equals to r sine theta. So we know that's the vertical component. And I can check, I can sub that in my expression. Where do I have the expression that's going to be? So theta e 1/8 theta. So I have r equals to theta e 1/8 theta. So let's sub that here. dy is going to be theta e 1/8 theta and sine theta, right? So it's a maximum distance, the further distance. So I need to put my dy by d theta equals 0, okay, to solve that. So let's see, what do we get? It's going to be 1 e 1/8 theta plus theta and 1/8 of e 1/8 theta. I'm applying product rule in this first one. So sine theta remains the same plus theta e 1/8 theta and sine's derivative is a cos theta and put it equal to 0. So now I can see that throughout I've got e 1/8 theta common. I will get 1 plus a 1/8 theta. And there is a sine theta outside as well. And minus, I will get a theta cos theta, right? And put it equal to 0. So I need to check. Oh, I had to put a plus sign over here. Sorry, my bad. That's the product rule. Plus. And hence, E1/8 theta is never 0. So you get theta cos theta plus a 1/8 theta plus 1 and a sine theta. I can write it like this equals to 0. That's shown. So that's it. And now I need to verify that there's a root between it. So how do you verify? You can just put it equal to a polynomial, like a theta cos theta, and plus a 1/8 theta plus 1 and a sine theta. And I need to check P of 5 and a P of a 5.05 and check the sign change. Does it occur or not, right? So this question was in radians. So I need to set my calculator first with radian mode. And let me just do that. Okay, so I go to the setup and radian, okay? So let's see, what do we get for 5? So 5 cos 5 plus bracket is going to be 5/8 plus 1 and times the sine 5. Let me just check, have I inserted it correctly? I think it's all right. So I'm getting a negative 0.1399, negative 0.1399. And next, I can just go back and put this 5 to be 5.05 in place of each of my theta values, 5.05. And here I need a 5.05 and a 5.05. Well, here goes nothing. And I get a positive value, 0.1336. So you will say, hence, sign change shows that there is a root in the interval, or you can say between 5 and 5.05. And that was it for question. Which one was this one? 5. Question 6. The points A, B, and C have position vectors given, respectively. Part A, find the equation of the plane ABC, giving your answer in the form this, and this is a Cartesian form of the plane, equation of the plane. Okay, so obviously the 3 points lie inside the plane ABC. That's why it's known as a plane ABC. So you can just use the right-hand rule. Just get the vectors AB and AC. You can do a BABC as well, or a CACB as well. But let's go with AB and AC, and then I can find the cross product to get the normal vector, right? Okay, so let's go with that one. AB is going to be OB minus OA, which is a 1, 2, 2 minus. I like to do my algebra of vectors as column vectors. You can use IJK as well. This will be 0, 2, and 4. And AC, on the other hand, is going to be OC minus OA, 2 minus 1 minus 1, and minus 1, 0 minus 2. This is a 1 minus 1 and plus 1, right? Okay, so now we find the cross product to get the normal vector. This is 0 to 4 and a 1 minus 1, 1. This will give me 2 minus a minus 4. So that's going to be 6i minus 0 minus a 4, negative 4j, and plus 0 minus a 2, which is just a negative 2, and k. So I've got my normal vector, but I can write this 6, 4, and minus 2 in the simplest form as 3, 2, and minus 1. So it's better to give your normal vector in the simplest form, but you can use any form. Eventually, your final answer will end up the same. So R dot n, which is 3, 2, minus 1, is going to be A dot n, which is like I can use any point on the plane to get this D. This D is the plane constant, which is like okay, let me just solve it over here, and I can put the D value over here. So let's say 1, 0, and -2 dot the normal vector 3, 2, -1. Let's get the scalar product 3 plus 0 plus 2. And that is a 5. So D's value is going to be 5. So now if you put R to be x, y, z, your final answer will look like 3x plus 2y minus z equals to 5. And that is the form I was required to give my answer in. All right. So again, I would encourage you to please like and subscribe my channel, and always comment if you have any doubts. So that way I can know that which points are like tricky and you need some more reinforcement on those, right? Okay. So next part. A point D has position vector I plus tk, where t should not be -2. Part B. Find the acute angle between the planes ABC and ABD. All right. So we know from the concept that the angle between two planes, and I know these are intersecting planes because you can see that A, B are common points to both, is the angle between their normals. So I've got my normal one, which is this one. So I need the other normal. For that, I can use AB and AD and find their cross product. So let's get AD. So D is 1, 0, and t, and a, on the other hand, is 1, 0, -2. So this way I get a 0, and t plus 2, right? Okay, so let's do the scalar product, ij, k. That will be like ab and ad. So ab is a 0, 2, 4. I think I got that earlier, and this is going to be 0, 0, and t plus 2. So that will give me 2 times t plus 2, I minus, rest is just a 0 and a 0. So my normal vector will be 2t plus 4, 0, and 0. Okay, so I've got my, let's see, I need to do normal 1. Angle between the planes is the angle between their normals. Dot n2 over n1 magnitude, n2 magnitude, and that will be cos of theta. So I'm using scalar products now. So that will give me 3, 2, -1 dot 2t plus 4, 0, 0 over. This is going to be 9 plus 4 plus 1 root. And this is just going to be 2t plus 4 squared and equals to cos theta. So I get 3 times 2t plus 4. This will be 9 and 10, root 14. And I've got another 2t plus 4. So these cancel, and that is cos theta. So theta is going to be cosine inverse of a 3 divided root 14. And I can go back to degree mode. You can give your answer in radians as well, but nowhere does it say in degrees. But if not mentioned, you can just give your answer in degrees, root 14. And that's going to be 36.699252, which is 36.7 degrees. And there we go. That's the angle between the two planes. All right, so why did they say that t should not be a -2? Because we can say that the denominator becomes 0, and that's a math error, right? Okay, so next part. Find the values of t such that the shortest distance between the lines AB and CD is √2. So we can use the shortest distance formula, but for that, I need the common perpendicular between the two AB and, let's say, CD, the skew lines, right? So what's that common perpendicular? So I can use the directional vectors like AB and CD. Let me just check if I have CD. Oh boy, I need CD, right? So let's get CD over here. that will be OD minus, oh, wait, this is C. I need OD, right? Which is a 10T, 10T. That's correct? Right. And minus OD. OD minus OC, which is a 2 minus 1, minus 1. So I get a -1, a +1, and a T plus 1. So -1, -1 plus 1, and T plus 1. That is CD, right? And AB, I have it. Good thing. 0, 2, 4. So we take cross product of these two vectors, I, J, K, to get the common perpendicular between the two skew lines, 2, 4. So -1, 1, and T plus 1. This will give me 2T plus 2 minus the 4, I, minus 0 plus 4, J plus 0 plus 2, K. So this will give me 2T minus 2. Okay, let's just write it as a column vector, minus 4 and 2. Or I can maybe simplify it as T minus 1, minus 2, and 1, right? Okay, so that's the common perpendicular. Now I use the formula. So for that, I need the vector AC. So 1 point on that line and 1 point on this line, right? So for AC, I need AC as well. Let's see if I've got AC already, which is a 1 minus 1 and 1. Good. 1 minus 1 and 1. So this goes like, I've got the directional vector for both lines. So this should be like AC and another thing, dot. I need the like AB cross CD, the path vectors, and this magnitude of AB cross CD, right? That's it. And that should be √2. So that's the distance between the planes formula. So this will be 1 minus 1, 1 dot. I've got this cross product already, which is a T minus 1 and minus 2 and a 1. And divide by, this will just be a T minus 1 squared plus 4 plus 1 and root that, and that is a √2. Okay, so I get a T minus 1 plus 2 and plus 1 equals to √2, or you can just multiply this whole thing. Root, let's say T squared minus 2T plus 1, and that's going to be plus 6. Okay, this cancels. So T plus 2. Let's square this side. 2 times the T squared minus 2T plus 6. Oh boy, let's see. T squared plus 4T plus 4. So 2T squared minus 4T and minus 6. Oh, my bad. Sorry. That's plus 12. Oh. T squared minus 8T and plus 8 equals to 0. So now you can show this in a quadratic formula, and I mean, I can straight away use the equation and quadratic, and that will give me 1 minus 8 and 8, right? And I'm getting 4 plus 2 √2. That is one possible value. The other one is going to be obviously 4 minus the 2 √2. So that's it. These are the values of t for which the shortest distance between two skew lines is a √2. And that's it for question. This is question 6. Question 7. The curve C has equation this. Part A. Find equations of the asymptotes of C. It's a rational function and an improper fraction. So for vertical asymptotes, you put your denominator equal to 0. And that's going to be, I mean, I can quickly solve that. It's just a 2-mark question. So I've got 2 and a -7 and a -4, right? So I'm getting 4 and a -1/2. X equals to 4. For vertical asymptotes, there is going to be 1 since the degree of the numerator and the denominator is same. So just take the ratio of the leading coefficients on the numerator and the denominator. That becomes 1. So y equals to 1 is going to be your horizontal asymptote. Part B, find the coordinates of any stationary points on C. So for stationary point, you need to find the first derivative. And that will be 2x squared minus 7x minus 4 and 4x minus 5. A minus sign in the middle, numerator as it is, and the denominator's derivative 4x minus 7. And this is divided by 2x squared minus 7x minus 4 whole squared. And we need to set it equal to 0 in order to get the stationary values. So when a fraction is 0, only the numerator is 0. 8x cubed minus 10x squared minus 28x squared plus 35x minus 16x and plus 20. Minus this will be 8x cubed minus 14x squared minus 20x squared plus 35x and equal to 0. Oh, the 8x cubes go away, and this will be minus 38x squared plus 35 and 25 and 6. That's 19x and plus 20 plus 34x squared, right? And minus 35x, put it equal to 0. This will be negative 4x squared. And this is, I'm doing a lot of mental math. 35 minus 19. It's going to be minus 16x and plus 20 equal to 0. And now we just need to solve this equation. I think I can further simplify this, and we don't need a calculator for this one. X plus 5 and an x minus 1 equals 0. So x is either a -5 or x is a +1. But we need the coordinates, right? So for the coordinates, I think it's better if I plug it in my rational function. 2 times 1 squared minus 5 times a 1 divided by, that's going to be 2 times 1 squared minus 7 times 1 and minus 4, right? I'm just checking, have I plugged in my values correctly? That looks all right. So 1 and a 1/3 is one of the possible turning point. The good thing is I can just go back and change my x with a -5 this time. This will be -5 and a -5 and a -5. That's good. 25 over 27. So -5 and a 25 over 27. That is another possible turning point, right? So these are the turning points. Next, I need to sketch it. So for sketching, I just need to, I need the intercepts with the coordinate axis. So let's take a curve, 2x squared minus 5x over 2x squared minus 7x and minus 4. I've kind of remember, like, yeah, that's it, but still I was checking. So put it equal to 0. This will give you the x-intercepts. So 2x minus 5 and x goes out. That is x equals to 0 and x equals to a 5 over a 2. These are my x-intercept. If you put x equals to 0, you get y equals to 0. So these, my origin is going to be the y-intercept. I've got the asymptotes already, which are -12. I'm just collecting the information, x4 and y1. So that's it. And the turning points are over there as well. So I'll just keep an eye on those as well. Oh, going to look horrible. I'm using the annotator to sketch it. This is X, this is Y. Put a 1 over here. That is Y equals to 1. Put a X equals to 4 over here. X equals to a negative 1/2 over here. And my roots, since this is a 4, this is a minus 1/2, 2, and a 2.5 here somewhere. And now I need the turning points. Oh, so this is 1. So 1 and a 1/3 is definitely going to be here somewhere. So the graph looks like this, and it has to stay with the asymptote like this. And now I need to check the other turning point, which is a negative 5. What's the 25 over 27? That's going to be somewhere near 0.9, right? So yeah, that's below. So minus 5 and a 0.9 here. Let's make it below. So another important crucial thing is we can check whether the graph intersects. It has to intersect somewhere once with the horizontal asymptote, right? So 2x squared minus 5x over this thing equals to 1. If I solve that, this is going to be 2x equals to minus 4, and x is a minus 2. Yes. So it does intersect at a minus 2 and a 1 somewhere. So the graph should look like this. And it should go as near as possible. Oh, I could have made it a bit better. Minus 2. So let's say it goes like this. A slight dip over here and then intersects like this. So minus 2 and a 1. This is a negative 5 and a 25 over 27. That's a 1 and a 1/3. That's a 2.5 and a 0. And rest. Now, this is crucial part. So when you practice, you know already that how do the rational functions for improper fraction looks. This one is with the horizontal asymptotes. Sometimes you get oblique asymptotes as well, the slant asymptotes. So if you want to be sure like why this part is above y equals to 1, you can sub in some values in your calculator. Like, okay, let me just show you. So if I take any value, let's say 8. So this can be a good way to realize that is this part of the curve above y equals to 1, the horizontal asymptote, right? Yep. So whatever you do, your values are going to be above the x-axis. So that's it. That's my sketch for this rational function. And part D, sketch the curve with equation this. Oh, this is easy. I can, okay, I'll make it again. But why that's easy? We just need to reflect the part which was below. This is y equals to 1. That is x equals to 4. That is x equals to a minus 1/2. So the graph was looking like this. And this part is now going to reflect up like this. The rest of the graph looks the same because that was on the positive side. And with practice, you can make much better. I'm sketching it horribly right now. I'm sorry about that. Okay, so 0 and a 2.5 and all the values which were there, the vertex and stuff, right? Okay. So now we do part E. Find in exact form the set of values of x for which this. Okay, so this means actually that your function is within 1 over 9 and a negative 1 over 9. So, okay, so 1 over 9 is going to look like here somewhere. Oh, that should have been a horizontal line. Okay, let's just make it this way. All right. So my critical values will look like this and this. So this is a 1 over 9. Okay, so you gotta be careful over here. So the actual graph was below. So once I will solve my function with minus 1 over 9. So that will give me this region and this outer region. Oh, you got to be careful with these two. So these two critical values will be found over here. So 18x squared minus 45x equals to minus 2x squared plus 7x and plus 4. So that's 20x squared minus 52x and minus 4 equals to 0. So let's just quickly solve this one. Equation, quadratic, 20 minus 52 minus 4 and put it equal to. So that's this is going to be this one 13 plus 3 root 21 over a 10, and this one is going to be 13 minus a 3 root 21 over a 10. So now I need to put again the function, but this time equal to a positive 1 over 9. So that will give me one of this region and this region, right? So 18x squared minus 45x equals to 2x squared minus 7x minus 4. That is 20x squared minus 38x plus 4 equals to 0. Yeah, that looks all right. So I can go to equation quadratics, 20 minus 38 and 4. Right, so one of the root is going to be this one. Looks kind of horrible. Let me just quickly check. Have I placed my values correctly? So that's going to be 18x squared minus 45, 2x squared minus 7x, and minus 4. So that's minus 38 and plus. Oh, that was a 16. My bad. Saved. The value was so huge, so I just thought that maybe I should check it again. So always test yourself. This looks fine. Yeah, it looks fine. Okay. So this one is a 19 plus 3 root 33 over 16. And this one is definitely going to be 19 minus a 3 root 33 over 16. So one of the possible solution set where your function is below will be this thing, 19 minus 3 root 33 over 16. And or this is going to be 19 minus 3 root 33 plus over 16 and x and 13 plus 3 root 21 over a 10. Now, the reason I'm giving my answers in third form is like I realize that they're saying exact forms, right? Okay. And that's it for this exam. And I'll be posting the other variants for this exam series soon. So one thing that I notice about my channel is that when I look at the analytics, I've found that many of you that watch the channel do not subscribe. Come on, guys, that hardly takes any energy, but it means a lot for the channel. If you found this walkthrough useful, do comment, like, share with your friends, subscribe to my channel, and keep following for more useful resources. This is Global Math Mentor over and out.